Hi everyone, my name is Shahnoor Kiani. I'm here to talk to all of you about current and novel methods of enumerating cloud assets. I'm a security consultant who recently started a new role at Root Shell Security. You might notice the slides say with secure on the bottom right. That's because all this research was done when I was working at with secure. You can see my socials listed here. I'll put at the end as well. I'm particularly interested in application security and cloud security. So if anyone wants to talk to me about that afterwards, I'd love to chat. I'm going to begin by giving a summary of AWS Cognito. And I'll talk about my experience learning about the service. I'll move on to current methods of enumerating cloud assets, and I'll apply these methods to find 300 active instances of AWS Cognito. I'll then move on to talking about certificate transparency logs, and I'll talk about how these can be applied to find cloud assets, and I'll conclude with some takeaways from the research. This is how I found 300 active instances of AWS Cognito exposed to the internet. Cognito is an identity provider. It lets you make a login page for your application, and it's hosted on AWS. It consists of user pools and identity pools. A user pool is a directory of users, and each user pool has many clients which interact with this directory. These clients can do things like log in as a user. They can change attributes of existing users, and they can even register new users, just to name a few things. Identity pools provide access to the AWS account for users. So what's so interesting about these login pages built on Cognito compared to any other login page? Why do we care about finding these login pages? Since it's built using AWS, it uses the AWS APIs to work. That means we can turn this page into this. This is the AWS CLI command for authenticating to a Cognito client using the user password authentication flow. On the back end of that login page of that application, this is what it's doing. The developer may not realize that users can instead circumvent the login page and directly interact with the client, and this can lead to an unmanaged attack surface. If this is the case, this could be exploited. So this is what the normal flow looks like. You can see myself on the left using the login page, and the page makes an API call to Cognito and authenticates myself to that application. But as an attacker, I can do this. I can use something like the AWS CLI to directly communicate with Cognito. The developer may have secured the web application, but they may have misconfigured the client which I'm now directly interfacing with. And if this is the case, this can be exploited. Before I continue, I just want to give a bit of background on how all this research actually came to be. It didn't start off with me wanting to find out how I could find other people's cloud assets. I just wanted to learn about how Cognito worked and how to break it. I found blog posts online talking about how it can be attacked. I used bug bounty write-ups. And I configured several instances on my own. And the AWS platform made this really easy to do. I could set up a new instance in minutes. And crucially, it gave me an insight into exactly what the developers see when they set this stuff up. This is really important from a cloud security perspective, because I need to see which misconfigurations could feasibly be made. And this diagram is a testament to this. Developers may not realize they're responsible for managing the whole attack surface of the API. In a normal application, they could get away with making sure the login page was secure. But since we're operating in the cloud, this new attack surface is introduced that I can now directly interface with. From my research, I covered a list of potential misconfigurations for Cognito specifically. I found in certain circumstances, an attacker could bypass password policies. They could register new users to the application even though the login page doesn't let you. This could allow you to access an application essentially unauthenticated. They could take over anyone's account and escalate their privileges to administrative levels within the application. And they could also get access to the AWS account using identity pools. And you can see more information if you're interested by looking up the With Secure Public Cloud Wiki, secwiki.cloud. Now, I had found a bunch of misconfigurations for Cognito, and I was excited to see if these were actually feasible. But there's one issue. I didn't actually have anything to attack. I couldn't use my own instances to test these misconfigurations because I was trying to test how feasible these configurations were in the wild. I needed to find Cognito clients exposed to the internet. And this led me to look into cloud asset enumeration. I'm going to now cover some current methods of enumerating cloud assets. Assets can be identified typically with a domain name or, in general, some identifier. What's important to know is that these identifiers have a common shape. For an S3 bucket, this is a bucket name, and you can see the following identifiers. On the top, we have an S3 URI, and on the bottom, we have a domain name. And both can uniquely identify an S3 bucket. By first looking at service and determining these, the shape of these identifiers, we can build tooling to brute force instances of these services. For S3, a lot of tooling exists already. One tool in particular is called S3 Scanner. It takes in a list of bucket names and it just checks if they exist and also does some basic enumeration to see if they can enumerate any permissions on it. Now, since these identifiers have a pattern, tooling can be used to automatically find them at mass in web pages. But what we need is a lot of data, specifically a lot of HTTP responses. We need to look through, have a lot of responses to look for identifiers in. We can use tooling for this. Web crawlers like Katana can be used to scrape web pages for URLs. And then we can use grep to filter these URLs to find identifiers. Additionally, you can use HTTPX, which is another tool which can make HTTP requests at scale to all of these URLs. And then we can look through the responses to look for identifiers. Websites typically contain JavaScript files containing the logic for the application. And this logic may include the logic it uses to interact with various cloud services. You might find a bundle.js file, and this is likely, if it uses a cloud service, it's likely going to contain identifiers for whatever service it's using. Finally, there are some other notable techniques which could be considered. Similarly to how we look through source code of web applications, we can look through source code of native applications as well. Wiz, in their talk, Scanning the Internet for External Cloud Exposures, they looked through the source code of native Android applications, and they found 30,000 Cognito identity pools. There also are some third-party sites which does most of the work for you. Grey Hat Warfare passively scans and lists the contents of various cloud services like S3 buckets, and anyone can just passively look at this website and just look at the contents of various buckets. Let's take it back to Cognito. I needed to apply these techniques to find instances I could test these misconfigurations on. But firstly, let's understand what we're looking for in the context of Cognito. We're looking for a client ID. Functionally, this is equivalent to an instance of Cognito that we can attack. They're about 26 characters long, consisting of alphanumeric characters, which is unfortunately too long to brute force. So that means that we're going to have to find them somewhere. When researching Cognito, I came across a feature which I found particularly interesting. And this was the Cognito hosted UI. It provides a login page which works out of the box. But interestingly, the default domain for this hosted UI is always a subdomain of amazoncognito.com. So that means if we find a URL with a subdomain of amazoncognito.com, it's likely going to be a Cognito hosted UI page. And in the URL, there's a client ID as a get parameter. And that client ID is what I was looking for. I use a tool called Get All URLs, or GAU. And this crawls for URLs who have a specific domain name or are subdomain of a specific domain name. In this case, I told it to look for subdomains of amazoncognito.com. It looks through several open datasets for you. For example, it looks through Open Threat Exchange, Wayback Machine, Common Crawl, and it looks for URLs for a specific domain. From this, I was able to find 1,659 unique client IDs. Now, this was great, but there's one issue. A lot of them were stale, meaning they were made a while ago and then since then have been deleted. I was able to leverage an AWS API call to determine if they were active at scale. By trying to authenticate to the client ID, it would tell me, hey, this is deactivated, or it would say, the login failed, meaning it was active. And I was able to do this across all the client IDs I had gathered. What I was left with was about 230 working active client IDs and unique client IDs. It's also useful to try to apply creativity to think of other sources of gathering asset identifiers. In my case, I was looking for backlinks. If you're unfamiliar what a backlink is a link from one page pointing to a different domain. And in the case of the Cognito hosted UI, that would typically be a backlink. So I would have my website and I would have a link to the something.amazoncognito.com as a backlink. And that would be the hosted UI. So I was able to leverage SEO tooling to find instances of these backlinks. SEO tooling, search engine optimization tooling, can be used to provide metrics for your domain. One tool I used allowed me to use the amazoncognito.com domain, and it would tell me metrics for that domain. And one of the metrics it told me was backlinks to that domain, and that included URLs. And inside that URL to the hosted UI were client IDs. Combining it with my original dataset, I was left with 282 unique and working client IDs. As shown before, these client IDs are really valuable. They're like gold dust to me. Similarly to how I could programmatically determine if they were active, I could programmatically determine if the instance was vulnerable. I could use the AWS API calls to try to sign up new users. Given a user, I could see which attributes were mutable, and that could perform a privilege escalation vector within the application. I could also instead try to look for identity pools, and this could provide me access to the AWS account. And the important thing to note is that all of this can be done at scale programmatically. I'm going to now move on to how I applied a novel method for how I applied certificate transparency logs to enumerate cloud assets. But before I describe this technique, I want to give a bit of an overview of certificate transparency logs. At a high level, certificate transparency logs are a place that anyone can go to view a list of all X509 certificates issued by various CAs. These are the same certificates used by web servers to encrypt traffic for TLS. And the reason that certificate transparency logs exist is because of incidents where some CAs were issuing certificates which should not have been issued, essentially. In 2011, a group was able to intercept half of the traffic going through Iran, despite them using TLS. And the reason is because one of the CAs was issuing certificates they shouldn't have been issuing. And since this CA was trusted by our browsers, this meant we as end users trusted those certificates as well. The web public key infrastructure depends on this list of root certificate authorities. Who they trust is essentially who we trust. Certificate transparency logs are a log of trust that make it clear to us who we are trusting. And over here you can see an example of an X509 certificate. So you might be wondering okay, why do we care about these certificates? Well, in addition to the public key, which is used for TLS, it contains some interesting information for us. You can see the issuer of the certificate, which is key for the technique later. Also some X509v3 extensions, and these typically contain more information about the identity of the person who the public key is for. For example, there's a subject alternative name, which is a quite a useful extension, which in this case contains more information about the domain name. A quick overview on how the certificate transparency log process works on a low level. It begins with a domain owner requesting a certificate for a CA. The CA creates a copy of the certificate called a pre-certificate. This pre-certificate, I'm just going to call a fake certificate because it's the same thing as a normal one, but has this extra extension. This extension is called a poison extension. It means that if a server tries to use it for TLS, the user agent won't accept it. So we can't actually use this to encrypt traffic. It's a fake certificate. The CA creates this fake certificate and sends it to the certificate transparency log servers. And the servers spit back something called an SCT. Sorry. This SCT, or signed certificate timestamp, is proof that this certificate has been publicly disclosed. The CA takes this SCT and takes the certificate and hands it back to the domain owner. So now the domain owner has two things: a certificate, which acts as a public key and proof that that public key maps to their identity, and an SCT, which they can give to user agents, and that acts as proof that the certificate has been publicly disclosed. So yeah, I covered that already. So this is an overview of the whole process. But at a high level, all you need to know is that certificate transparency logs are a publicly auditable log of all X509 certificates issued by certificate authorities. So in this case, now if a malicious group manages to trick a CA into issuing a certificate that they shouldn't have, at least it's public, so everyone can see that's happening, and someone go like, hey, maybe you shouldn't be issuing that certificate. To reiterate, at a high level, all you need to know is that there's a public log where anyone can see all the TLS certificates being issued by CAs. AWS has its own set of CAs, and I found this website called AmazonTrust.com that lists all the information related to the certificate authorities it uses. And interestingly, it uses 4 root CAs for the certificates it issues. So when you use a certificate issued through AWS, it uses ACM, Amazon Certificate Manager. And this uses one of the 4 root CAs displayed here. When I found this out, I asked myself, what happens if you look for the certificates issued by one of these 4 CAs? CRT.sh is a Postgres database with a website front end. It allows you to look through certificate transparency logs easily using its using a website. So as a proof of concept, I use CRT.sh to look at the certificates that one of these root CAs have issued. And from the diagram, you can see there are about 23 million certificates in total issued by one of these root CAs. And each one of these certificates, each one of the 23 million, is typically linked to a domain name. And this domain name is likely going to be pointing towards a cloud asset because the certificate for it is issued through ACM. Subsequently, I built a tool which extracted as many of these domains as I could. And I got about 168,000 domains due to limitations from CRT.sh. It has crashed quite a lot. I could have gotten more certificates if I directly queried the CTL servers rather than CRT.sh. It's like a middle person between the end user and the CTL servers. Now, what I had was a list of domains. And these domains were from certificates issued by the Amazon root CA. They weren't necessarily cloud assets, but is likely. And I can do some transformations as further research to filter this list. I could try resolving all of the IPs and just getting rid of the ones which didn't fall within the AWS API IP ranges. Additionally, I could use some of the tooling described earlier, and I could try to find URLs for some of these domain names. If it's the case, that could give me some information like asset identifiers. For example, if I'm looking for Cognito, I could use the URL. I could look for the client ID and the get parameter. Cloud asset enumeration is a new research area. It's a subsection of attack surface management, or ASM. Unmanaged assets present an overlooked ripe attack surface for hackers to exploit. Now, the intersection with this with cloud security is particularly interesting. The shared responsibility model is conducive to producing an unmanaged attack surface. The shared responsibility model, by the way, is a model which AWS operates on. And it means that AWS are responsible for some things, like managing the infrastructure. And the developers are responsible for other things, like ensuring the stuff is configured securely. But when developers apply typical development practices to the cloud, they may not. They may assume that since it's built on the cloud, it's automatically secure. This is wrong, and because of this, cloud asset enumeration is a really interesting and powerful research area to go look into. The platform, because of the shared responsibility model, the platform assumes the developer knows that they have to take care of something, but the developer may not even know that thing is an issue. Cloud asset enumeration is a research area which is growing. Ingenuity can be applied to find new methods of enumerating these assets. And the impact of finding the right one could be catastrophic unless we find it first. Thank you everyone for listening.
Any questions?
So if you were running your own cloud services, obviously this is looking at other people's attack services, I guess, rather than be able to run and check against search stream or whatever else I'm checking against. Is there can I get that data out of Control Tower or something else in AWS to help me understand how many times we've got Cognito running? I know you should know, but what if I don't?
So do you mean like assessing your own assets? I think there are some services in AWS which give you an overview of your account. I'm not sure specifically which ones there are, but there are also a lot of offerings which provide that. This is more more in general, just looking at things related to your organization rather than the specific cloud. Yeah.
You mentioned
yeah. Yeah. So this is a really important point for this sort of research. I want to stay away from intrusive tests. And when it came to adding users to user pools, I didn't do that. And one of the reasons is that it's seeing someone try to log into your account, log into your login application is less scary than seeing a new user in your in your application if there's not meant to be any users. But absolutely, yeah. So when it comes to this stuff in general, you can classify stuff into passive, active, intrusive. And passive in general is okay to do because it can't directly be attributed to you. Active is probably where you want to start drawing the line, and intrusive you shouldn't really go for. But that's a really good point, yeah.
Could you disclose the businesses that you discovered in these configurations?
So again, I didn't actually do the scans to look at the misconfigurations because they were intrusive. And the stuff that I did find, this is more as I wanted to use this as a precursor to show people that, hey, there's this research area and it can be quite impactful. If you find, it's a lot easier to find, it's a lot easier to attack something which hasn't been looked at very much rather than something that has been looked at quite a lot, but you need to find that thing. And cloud asset enumeration is quite good for that. So I didn't actually try to run any of the exploits against that because again it's too intrusive.
What's the reasoning for using the web application as a query?
Yeah, it's easier. That's pretty much it. But you do get a lot more coverage if you use the certificate transparency log servers directly. And interesting, since you can just, by the way, these servers, they just host all these shards of data. You can just download all of them and then query them locally. And essentially, this can almost be done passively because a lot of people will be downloading this data anyway. So, given more time, I would definitely prefer to have done it, by just downloading all the data from the CTL servers. Yeah.
organisation exposure. I know quite a few organisations that have shadow AWS instances running helps for able to find all those instances.
Yeah, absolutely. So this is quite a big project to build a tool around. There are definitely organizations doing it already. ASM is quite a growing part of industry, and for a good reason. I'm always of the belief that it's a lot easier to attack something which you don't put that much effort into securing, and ASM is really good for that. So I'm planning on making some tooling around it, but it does take a lot of effort, and there are definitely organizations who have put a lot more money and person power into that. All right.
Any more questions? All right. Thank you very much.
Thanks, everyone.